for differentiation, last year we learned like differentiate x to the power of n, which gives us n times x to the power of n minus 1. And also we know that the derivative for a constant will be 0. The reason is when you got y equals to 4, for example, then the graph looks like a horizontal line. The gradient will be 0 anywhere. So that's why the derivative of a constant is 0, because the gradient at any point will be 0. And to x to the power of n that equals to this one, n can be anything. Okay, to make it more general, because in the book it gives integers, negative integers, rational numbers, negative rational numbers in different exercise. I don't want to go through like that many steps. So I just say x to the power of n, the derivative will always be n times x to the power of n minus 1, which n can be anything. Okay, anything will work. If you times a constant in the front, the derivative will be times with that constant as well. And the only thing we can do is x to the power of n plus x to the power of m. Then we can derive or minus, which when you times them, you can't really do derivative and then times them. So that's the product rule and quotient rule, which we'll learn later. So before we start the question, what you can only differentiate is x to the power of n. Okay, only you can derive that thing, or with some constant in the front. That's the only thing you can derive. X on the denominator, no, you can't derive in this form. X in the square root, no, you can't derive that form. So everything needs to be changed into the index form. Okay, an index form, like with a power of n. So before we do that, we should know the rational indices, a x to the power of a over b. That is the same as x to the power of a, then the b's root. Okay, x to the power of a and then take a b's root. So that's what we need to learn. And also 1 over x to the power of just 1 over x. That's x to the power of negative 1. When it's on the denominator, that will flip it up and with a negative sign. Okay, with a negative sign. The 1 over is a negative index. So we need to learn this before we start to do those questions. And another useful rule will be a plus b over c. That will equal to a over c plus b over c. That's another way we can separate fractions. When you have multiple terms on the numerator, you can separate that by this method. Well, if you have a over b plus c, that is not equivalent to a over b plus a over c. Okay, be aware of that. When you have things on the denominator, you can't separate by this way. But when you have this on the numerator as a plus b over c, you have a over c plus b over c. This one will work. Or you have multiple terms, more terms on the numerator, we can do this as well. Okay, let's have a look at the questions. Example 1. So fx equals to 4x cubed minus 2x. Well, it's all x to the power of n. So this one is easy. But remember, you are asked to find the derivative. You will say f dash x. That equals to 12x squared minus 2. 12x squared minus 2. Well, this one's easy. The second one, f dash x equals to, well, that's a minus 5 over 8 times 4 x to the power of 3 plus 3 over 4 times 3 and then x to the power of 2. Well, we have a 0 because 22 derivative is 0. So f dash x equals to minus 5 over 2 x to the power of 3 plus 9 over 4 x to the power of 2. Okay, shouldn't have any problem with that. Okay, for C. C is not plus. Okay, we have multiplications. We have one function times another function, which is not good. You can use product rule, but I don't think it's quicker to use product rule here. So, and also we haven't really officially learned product rule this year. So what we can do is expansion. Okay, expand this and then derive it. It's times, well, it's x times with x. That's not working. So y will equals to 2x squared plus 4x minus 3x minus 6. So that's 2x squared plus x minus 6. 2x squared plus 4x minus 3x and minus 6. And then the notation will be dy dx. It's only function notation. You can say f dash x or g dash x. But when you have y equals to some x, you will say dy dx. That's the notation for derivative. And that gives you 4x plus 1. That will give you 4x plus 1. Okay, D. Again, x can't be on the denominator. X can't be on the denominator. So I need to make it, flip it back. So y equals to 2 times x to the power of negative a half. Can you see the negative 1 is because 1 over and the square root give you the half. So that's 2 times x to the power of negative a half. And plus 5 to the power of 2 on 3. Okay, 5 to the power of 10. Well, you don't really need to do anything to this because it's a constant. That will become 0. Derivative will become 0 anyway. But that's what you can do, 5 to the power of 2 on 3. Therefore, dy dx equals to 2 times negative a half is negative 1. That's negative x to the power of negative 3 over 2. Negative a half, well, I'll do step by step. Maybe 2 times negative a half times x to the power of negative a half and then subtract 1. So dy dx is negative x to the power of negative 3 over 2. Well, if you don't like the negative, I can say that's a negative 1 x to the power of 3 over 2. Or we can even expand that further. That's square root x to the power of 3. Okay, next one, E. I think most of us struggle so much on this one, like don't know what to do with that one. Well, what I have done to this one is z equals to 2t3 over 4 times, well, there is a times, okay, it's not 4 to the power of, not 4 cube, it's the t to the power of 2 over 3. I should write a times in between. So that's 4 times t 2 over 3 and plus 3t over 4 times t 2 over 3 minus 1 over 4 times t to the power of 2 over 3. Okay, I also see some of you write this times a quarter t negative 2 over 3 and then do expansion. I also see that as well. You can do this as well, expand it then, or I can just separate directly like a over c, b over c and d over c. And then what I can have is, well, this is a fraction with t divided by t, which is not good. So what I can have here is a half t to the power of 3 is 9 over 3, so that's 7 over 3, plus 3 over 4 t to the power of a third, minus a quarter t to the power of negative 2 over 3. That's how I can simplify it. When you have the same base, you will subtract the power when you divide them. Okay, so this one we can see that's 1 times t to the power of 0. Because that's a 1, that's t to the power of 0. So 0 minus 2 on 3 is minus 2 on 3. Then the notation will be dz dt. Okay, dz dt, not dy dx now. It's dz dt equals to, well, a half times 7 over 3 t to the power of 7 over 3 minus 3 over 3 plus 3/4 times a third minus 1 minus 1/4 times negative 2 over 3 t to the power of negative 2 over 3 subtract 1. And that gives you 7 over 6 t to the power of 4 on 3 plus 1/4 t to the power of negative 2 on 3 plus 1 on 6 t to the power of negative 5 on 3. That's the derivative. Okay, so the thing is how we can separate that. Okay, how we can separate that. Okay, the next one's notation is interesting. This notation is, well, if I cross that, I said that's y. And then I said y equals to 3x cubed minus 4 over x plus 1. That will be the same. So this is ask you to derive the thing in the bracket. This notation means derive the inside. So it already means the derivative of that. So we can directly write equal sign here. That equals to, this is the derivative of this. Okay, the whole thing means the derivative of the thing in the bracket. So we have 4 over x. We don't want 4 over x, but we want 4 to the power of x to the power of negative 1. 4 times x to the power of negative 1. So this equals to 9x to the power of 2 plus 4x to the power of negative 2. That's 9x to the power of 2 plus 4 over x to the power of 2. Okay, which is easy to derive. I just want to know, to familiar with the notation. Okay, next question here. Find the coordinates of the point and the curve with the gradient of the tangent at the point given value equals to negative 6. So basically I need to think about gradient. G dash x is the gradient. It's negative 3x to the power of 2. And then I want the gradient equals to negative 6, which is negative 3x to the power of 2 give you negative 6. And x squared gives you 2. And then what is x? What is x? Plus minus root 2. Okay, plus minus root 2. So g root 2 equals to 4 minus root 2 times root 2 times root 2. That gives you 4 minus 2 root 2. And g negative root 2 gives you 4 minus negative root 2 times negative root 2 times negative root 2. And that equals to 4 plus 2 root 2. So the coordinates is root 2, comma 4 minus 2 root 2 and root minus root 2 and 4 plus 2 root 2. Okay, example 3. I haven't asked you to do example 3 because I want to go through this question carefully with you. Can you sketch this, quickly sketch this quadratic for me, please? I just want the turning point. Okay, so we have some quadratic loops like this. We have turning point at 2 minus 2. Do you have that? Yes? Okay, my question now is, when is an increasing function? Like x belongs to what is an increasing function? 2 to infinity? What kind of bracket will have? Well, this must be round bracket. Well, my question is, do we include 2 or do we exclude 2? Square bracket or round bracket? Should we include turning point for increasing function? Is inclusive. Is inclusive. So for decreasing function, we will include the 2 as well. Okay, the turning point will be included in both increasing and decreasing function. If I'm just talking about whether it's an increasing function or decreasing function, the turning point must be included. Okay, very, very important thing. You must include turning point in increasing and decreasing function. Every year, so many students get this wrong. And last year, we did have test this for 2-mark question in the set. Half of the class get it wrong, even though emphasized a lot of times. Okay, so you must remember this, and this must be tested. Okay, so for increasing and decreasing function, because we know students always get this wrong, so that's why we always put the question on the test. And then again, it's just confirmed, yes, students always get that wrong every year. So turning point must be included in the increasing and decreasing function. When is not included? When I say which part of the graph get a positive gradient, you're not going to include the turning point. You can see the difference between the question. When is an increasing function? It's nothing to talk about with the gradient yet. You will include the turning point. But if I mention the gradient needs to be a positive gradient, then we don't include the turning point. Okay, we don't include the turning point. So for this question, the first one asks x such that f dash x greater than 0. Greater than 0. So what I will have is x belongs to 2 to infinity, exclusive, because positive gradient will not include the turning point. Turning point gives you gradient of 0. Yes, turning point gives you gradient of 0, but is the part of increasing function. Okay, it is part of the increasing function. That's completely 2 types of question. Talk about gradient or talk about increasing or decreasing. That's 2 types of question. There's a little bit connection between them, but like it's separate things. It's 2 different things. The next one asks you when is it less than 0. Less than 0 is negative infinity to 2, exclusive as well. And number 3 is x equals to 2, or you can say x belongs to 2. Because the gradient equals to 0 is the turning point. But equals to 0 doesn't mean it can't be increasing or decreasing function. It still can be part of increasing and part of the decreasing. So what I've shown you here, left hand side and right hand side, there are 2 different questions. Increasing function will be include turning point, but gradient positive or negative will not including the turning point, because turning point give you gradient equals to 0. Alright? So I will say, when you have gradient greater than 0, it must be the increasing function. But when you say x belongs to 2 to infinity is increasing function, that doesn't give you gradient greater than 0, because gradient could be 0, could be at 0 as well. So I can go for positive gradient must give you increasing function. So for those x's must be increasing function as well. But for tells you some part of the function is increasing function, that gives you positive gradient or zero gradient, because that will include the turning point as well. Okay, when I say it's a positive gradient, the graph must be increasing. When I say it's an increasing graph, that will include the positive gradient part and the zero gradient part. So that's something you need to pay attention. Okay, moving on to the next page. Well, first two questions just ask you to do first principles. You have fun by yourself. I'm not going to go through that. Example 3. Well, example 3 is easy. I'll just need to rearrange the equation a little bit. That's 2 times x to the power of negative a half plus x to the power of negative 5 over 4. I hope you can see that. The on the denominator gives you negative, and then the root x gives you a half, and then the fourth root of x to the power of 5 gives you 5 over 4. Then the f dash x equals to 2 times negative a half times x to the power of negative 3 over 2 minus 5 over 4 times x to the power of minus 5 over 4 subtract 1. That equals to negative x, negative 3 over 2 minus 5 over 4, x to the power of negative 9 over 4. 4 over 4, 5 over 4 is 9 over 4. Okay, next one. Well, next one, if you use my y to separate, that's 3 over x to the power of 3 plus x over x to the power of 3. So fx equals to 3x to the power of negative 3, and that's 1 over x to the power of 2. So that's x to the power of negative 2. So f dash x equals to negative 9 x to the power of minus 4 minus 2 x to the power of minus 3. That is minus x over 4 minus 2 over x to the power of 3. Okay, next question, A and B. Can't do C and D yet. For A, well, if you know the chain rule, you can use the chain rule formula to do it, but because I don't really teach the chain rule yet, so I will do expansion. Well, because it's a square, if it's like quartic or like power 5, it's very hard to expand, then we use the chain rule. But because it's only a square, like I can easily expand it. Maybe it's easier to do expansion rather than doing chain rule in this question, because it's easy expansion question. So this equals to 4 minus 20 root x and plus 25x. And that equals to 4 plus 25x minus 20x to the power of a half. Okay, so how I can represent the derivative? I will say d dx of this. Okay, there's no y equals 2, there's no fx equals 2, so I need to make the notation d dx of that equals to, well, equals to what? 4 becomes 0, 25x is 25, minus, that's 10x to the power of negative a half. Half minus 1 is negative a half. So that's 25 minus 10 over root x. B, well, again, B is this type of question. That's 2 over x to the power of 2 plus, well, root x is x a half over x to the power of 2. That equals to 2 times x to the power of negative 2 plus x to the power of negative 3 over 2. Half minus 2 is negative 3 over 2. So I'll say d dx of this equals 2 minus 4x to the power of minus 3. You subtract 1 is minus 3. Minus 3 over 2 x to the power of minus 1 is 5 over 2. So that's minus 4 over x to the power of 3 minus 3 over 2x to the power of 5 over 2. Or I can say that's root 2 root x to the power of 5. Why I can't do the other two questions? Well, if you know the chain rule, you can do them, because I can't separate the x out from the cube root. Like, I can't expand it or I can't simplify it. I can't rescue that outside of that root. So that's why I can't do it yet. Same as the negative a half. I can't get rid of the square root for this question. So I'll leave it like this first, and then next week when we talk about the chain rule, and then we can come back to do those two questions. Any questions from these revision problems? Very important thing, well, the most important thing maybe is the example 3. You know the increasing and decreasing function. We will talk about that more later in chapter 10, but it will be good if you can remember it now. Any other questions?